Welcome to part 2 of this amazing adventure we've embarked on. In the last video, we wrote all the code we needed to generate a proto file and send it over from the client to the server. In this video, we'll make use of the services from the cloud, having our server code run on top of an EC2 instance in a Docker container, as well as uploading our generated files to an S3 bucket. At the end of this video, we'll have a working tool that we can show off to the world. Alright, I'm on AWS now, and I'm going to navigate over to the IAM console. And here we're going to create our own user, which we'll use to grab special keys so we can access our S3 buckets upload files to. I'm just going to call it server that generates code, and I'll just give it programmatic access. I don't really care about adding a user to a group. We're just going to give it that policy S3 full access. And just make sure you have S3 full access and it only has programmatic access. We'll create the user, and we're going to grab two things that are very important to us. So first thing is the access key ID. I'm just going to comment it out down here. Just write it down wherever you're comfortable. So yeah, first I'll make 2 lines just so I can comment out the 2 fields we care about. Nice, so I'm just going to paste the access key ID there, and then the secret access key, you can only see this once, so make sure you get it well. Paste it down there, very cool. Now that that's done, let's go ahead and create our S3 bucket. Let this load, and create a bucket, and we'll just call it my gRPC files. As far as like the options go and the permissions, we can just skip all that for now. That looks fine. Let's create this bucket. Cool, there it is. Now in the permissions, this is where things are important. So I'm going to turn off the block all public access. And this is so that we want people to be able to get links from our bucket, also upload to it. So as far as public access with anybody goes, they'll be able to list the objects. So they'll be able to access an object by its URL, right? Because we want to share generated file URLs with this tool. With that being said, yeah, turn it off. Just confirm it. Nice. Now here's the bucket policy. This is in the description, so don't feel like you need to type this out. But what this policy does is it allows our IAM user to only allows our IAM user to upload, and then everyone else can just read files. So only one person can mess with the bucket, and that's it. All right, here is our CORS policy. This is just specifying HTTP methods that we can use to talk to the bucket, and this is also in the description. Nice. Now I'm back in our VS Code project folder, and I'm going to make a new class called S3 Handler. And this class is just going to contain all the logic for uploading files and also listing the uploaded files. The first thing I'm going to import is Boto3 and Boto Core. If you don't have these installed on your computer, you can just do Python or Python3-m pip install and then both names, so Boto3 and then Boto3 core or Boto Core, sorry. But remember that we're going to run this on EC2 in a Docker container, so it's not really like absolutely critical that you have this installed. We're just writing it out. Time to change our indenting to 4, and 2 class variables we'll need are going to be the IAM users, secret keys, secret strings. If you're committing this to GitHub, don't commit that string. It'll be deleted on my end by the time the video's up, but definitely don't want to show other people this, as anybody with those keys will be able to mess with your AWS resources. Also added a S3 class variable right there, and we're going to make use of the boto3.resource. Going to say S3 in a string, and then 2 parameters that we send in is access key ID and AWS secret access key. And they'll just be equal to whatever we put up top. And then config, very simple. You just use the config from Boto Core. This is all just like getting set up here. You don't really need to, have this memorized what each parameter does. Nice. And next thing we're going to do is we want to have a class variable that's going to keep track of the bucket based off of that S3 object you made. Okay, let me grab those strings, paste them in one, paste the other one in, nice. And then if you remember our bucket name, it's my gRPC files. Cool. I'm not sure why that's redded out, but it works. So guess VS Code just being kind of weird. Nice. Now with that being done, let's make another function which is going to handle the upload to the S3 bucket. So we'll just call it upload file. And it'll just take 2 parameters. So the file path, this will be the path to the generated file. We'll call this for each time we want to upload a file. So if we're uploading 4 files, we'll call it 4 times. And then the second path is the directory. And the directory is going to be that random UUID string, just so we can, logically separate the generated files on the S3 side. So we'll make a path. This will make sense in the future when I show you how this gets uploaded. And then we're going to open a generated file with the read byte option. And then we're going to use the file bucket class variable, the put object method. Very simple. The key pretty much just means where we want to put it. So it'll be in a random folder name / the generated file name. And the body will just be the data. The data of the generated file, that is. All right, nice. Now that that's done, let's go ahead and go back to our server or our proto file generator class on the server side. And we'll make a new class function called, handle S3 upload. And what this will do is this will go in the directory where we've generated all those files. And for each file in that UUID directory, we will upload it to S3. Obviously, of course, we don't want to upload the proto file. There's really no reason. Why would we do that? So create simple for loop, and we'll make use of the OS list dir. I'm putting a dot in there because that means current directory. This is the logic for, if we want to check if the file is not a proto file. So if the file doesn't end with .proto, then we'll go ahead and upload it. Yeah, so we'll put a comment there. We'll go ahead and handle that in a second. In the constructor for proto file generator, or up top first, let's import the class. So from S3 handler, import the class. And then right here, we will make a class variable called S3 handler. We'll just make it S3 handler class object. That sounded kind of weird. I've been saying that word too many times. So let's say something else. Okay, so we'll upload a file. And it will be the file in the directory. That'll be the name. And then the directory name is the UUID directory. And I just called it from that handle, proto generation or handle code generation. Now if I rerun this, keep in mind it's going to take some time because I have that 15-second delay still on the server side on line 66. But there it is, nice. And it got uploaded into that, UUID directory, and here's all our uploaded files. Very, very cool. We can see that we use the IAM users keys and it worked correctly. Got rid of that 15-second delay. Let me try it again. Let me refresh this. You'll see a new directory was made, and you can go in there and, although they're the same exact files, they're generated 2 different times, so there's 2 different directories. Cool. Back in the S3 handler class, I'm going to make one other function that we need, which is obviously getting the URLs, because we need to let the client know how they can access their generated code. This is just going to take a directory parameter, which will just be, the name of the folder that the code's in. So we're defining a dictionary on line 28, and I'll show you why, because we're going to map file names to their S3 links. So we'll list the directories contents, and then we'll create a dictionary, which we have on line 28, like I said, and then we'll just populate it in this for loop. So we can use the file bucket.objects.filter method from Amazon's, Python module. First thing we want to grab is the file name. But before I do that, why don't we just print S3 object just to see what we're messing with in this for loop. So after the handle S3 upload, I'm just going to call self dot. Actually, I should make a new class, or new method. So I'll call it get file URLs. It'll just take it won't take any parameters. And then we'll call on the object get file URLs, with the current UUID directory. Nice. So you can see right here, the key is what's important. See how it's like random name / generated file? Nice. So with that being said, we need to grab the file name first, which we can use with the split method. And we'll just split it by / and then we'll just get the very last element in that split array. And then for the file URL, it's always going to be the same. So you can just do https / your bucket name and then .s3.amazonaws.com / and then just the making it a multi-line string, by the way. So then it's just going to be, or maybe not, we'll just do a / and then we'll do S3 object and then key. Yeah, I'll just do it like that. It'll be a multi-line string. Nice. Now with that being said, we want to populate this dictionary, right? So the file name will be mapped to the file URL. And then after the for loop is done, we'll just return a result. Very nice. So now I'm just going to print this, dictionary mapped out. Let's go ahead and rerun this. Let's take a look. Boom. All right, so you can see, let me copy this to like a new area so we can see it mapped out. You can see that we're mapping correctly. We're mapping the file name to the URL that it's at correctly. And all we got to do now is just quickly return this to the user. And we'll be finally done with all our code. And then we can go about throwing this into a container on EC2. And we are done, guys and gals. So now check this out. I'm defining a variable called files. It'll just be assigned to whatever the URLs are, and we'll return it. This will obviously go back to the server. And then that's it. We'll just return the files as JSON back to the client. We'll handle. Cool. Now in this file, we're going to go ahead and assign a variable to the call generate API. Obviously, that'll be the JSON response from the server. I'll just call it response for now. And then we're going to make another function called, let's just print the file URLs. And this will just take the file dictionary, which is pretty much the JSON response from the server. Right, so like in the demo, we'll print something saying, hey, your files are successfully generated. And after that, let's just print the file name in the keys. So we'll just print, it's a for loop. So we're iterating it over the dictionary keys. Remember how we mapped it in that example? So we're going to just, print out file name, map to the file dictionary. Nice. There you have it. So let's go ahead and call on this method. So just self.print file URLs, and we'll send in response. .json, of course. And now let's rerun this client. Boom. Your files have been successfully generated. And there it is. Let's click on a link to see if it works. And then what do you have it? There you go. print_pb.js works. Open this in Vim really quick. Oops. There it is. Look at that. Nice. Only one thing left to do. Docker and EC2. We're done. All right, back on AWS. I'm in the EC2 console, and let's make an instance to run our server code on top of. Selecting an AMI, let's just do the Ubuntu server and just use T2 micro. That's more than enough space we need to run a Docker container on. Don't worry about any of these extra configurations. Launch it, and then we're going to make a new key pair just so we can SSH into it from our terminal. I'll just call it gRPC gen. Now, let's go ahead and make this EC2 instance launch. Nice. All right. Now, back on the EC2 console, we're going to go ahead and create a security group. And this is so that we can configure how we want to talk to this instance via HTTP and SSH. Call it gRPC server security. We're going to add an outbound rule so that, didn't mean to do that. We're going to add an inbound rule. And first one that we definitely need is HTTP, obviously. The instance should be able to accept HTTP traffic on port 80 from anywhere. And a description, we'll just say cool rules for our code generation server. All right, now we still need to add some more inbound rules. So I'll just create it. No, we'll just go ahead and edit this. All right, I'm going to add a couple more inbound rules. Another one we need, which is really important, is SSH. If I could just find it. There it is. And from anywhere again. So, port 22, the vibes. Nice. Now, keeping in mind with your key file, you got to make sure that you only have sudo access with it, so you can run that command on Linux so that you can only access this file with sudo. I'm going to copy and paste the command from the EC2 dashboard to SSH in there. So now I'm in here. If I do, df-h, this just prints out the space. You can see that I have about 6 gigs available, which is plenty of storage for installing Docker and whatnot. All right, I'm going to make a requirements.txt file within our EC2 folder. And this is just so we can track all the Python dependencies we need. Link is in the description. No need to copy and paste that. Now here's our setup script. This is going to be ran when we spin up our Docker container on the EC2 server. And why is it going so fast, you wonder? Well, honestly, I would just take it from the description to just copy and paste it if you're trying to follow along. But really simply put, what this is doing is when the container wants to get built, we need to install some extra things like we need Node.js, some gRPC tools for generating. And we're also going to install our Python dependencies from the requirements.txt. Now it's time for our Docker file. So this is also within the EC2 folder. You can take this from the description. I'm going to use the Python 3.8.4 slim buster image. It's pretty small. Just specify some work directory to, get this thing going. And because it's a buster image, we can use the apt commands. I'm going to copy requirements.txt. I'm also going to copy setup into the container. I'm going to run setup. Now, I made a mistake here where I did the array syntax, and that's completely wrong. You'll see that I'll fix that in a minute. After we run setup, I'm going to copy everything from the host directory into the container, expose port 5000, and then the command is just going to run the server python3 server.py. Now you might be wondering, how are we going to get this container onto the EC2 instance? And the answer is treescale. Treescale is a really cool service where you can push your built Docker image to, and it's really simple to create an account. You just give a username and password and you should be good to go. Now on treescale, I'm going to go ahead and create a new repository, and I'm just going to call it EC2 proto generator. And then a short description, you could really put whatever you want or nothing, it doesn't matter. Now you can click on this repository and we're going to build this Docker image over here and push it. First thing you need to do is you need to do sudo docker login -u, give your username, and then -p, that's just your password. So, I already logged in, so I'm not going to do it, but you can see that these commands are also going to be in the description. Just go to that link and you'll be able to log into treescale and push stuff to it. All right, now in the EC2 directory, let's go ahead and build the Docker image from the Docker file we created. And after the -t flag, which is for tagging the image, let's just match it to the name of the repository. So mine's that /EC2 proto generator. And after we run it, I'm sped it up. I've hit enter, and there you go, it worked. Nice. So now we're going to push it with that second command on line 3, docker push repo treescale.com / your username, and then just, EC2 proto generator. This will take some time, but after it's done, it should be on treescale. I also sped this up just so we could see it happen. Nice. I'm going to kill the server. And let's SSH back into the EC2 instance. Now, we're going to do the same. Actually, wait. The most important thing is we need Docker. So you can just do sudo snap install Docker on your EC2. And then we're going to just, sudo docker pulling the container from treescale, which you just pushed from your local computer. Nice, just pulled it. If I do this very long command, docker run -p map 80 to 5000, give it a name. We'll just call it EC2 proto generator. And then after, you see that I've supplied the URL, or pretty much just the image name, including the treescale repository at the end. Once I hit enter, boom, it's running. So easy. And now we're back in our local terminal. Before I test this out, finally, let me change the server URL to whatever's on EC2. You can see that on the console, it'll say the IPv4 public IP address. And I switched to S3 just for a second, just to show you how it's going to work. Now, let's do this. So I'm going to run it, Python proto CLI print proto, specify languages, boom. And let me grab the folder name right here. Let's search for this. As you can see, our Docker image running in EC2 function just like the local server we were running, except now it handled it in the cloud. Let's download this file, take a quick look. And wouldn't you know, just like the demo, successfully created. We didn't have to do any complex commands, just upload a proto file, specify what languages we want, we're done. Thanks everybody.